Today we are entering the third big topic of the course. We are going to start seeing special products. Special products are a specific structure of an algebraic multiplication that allow us to do a simple process to obtain the product of a specific algebraic terms without doing the whole algebraic multiplication. So it's like a simple rule that will help you to do a specific operation without doing the full operation. Only we will need to remember these rules to apply them and not to do the whole operation. So the first that we are going to see, it's the square of a binomial. The square of a binomial, the rule says the square of the first term plus 2 times the product of both terms plus the square of the second term. So in this case, we can see here on the bottom part the rule. So if we have a binomial squared, the rule it will be the first squared plus 2 times the first and the second one multiplied plus the second one squared. Let's see why it's this rule applicable. So we will need to demonstrate this one. So when we have a binomial squared, it's like having that binomial multiplied 2 times. So in this case, it's like having the multiplication between the first term that multiplies both of the terms on the next parenthesis and the second term multiplying both of the terms in the second parenthesis. So it will be x times x, it's going to be x squared. Then x multiplied by y, it's going to be plus xy. Then y multiplied by x, it's going to be again xy. And finally, y multiplied by y, it's going to be plus y squared. So if we saw, we have two like terms, xy plus xy. So that's why the rule will be x squared plus 2 times xy plus y squared. And from this specific one, it's the one that will help us to have the rule of a binomial squared. So that's why if we saw a specific binomial to the square or to the second power, we can do it like only applying the rule. The first one is squared plus 2 times the first one and the second one multiplied plus the second one squared. So let's see what happens when we have a x minus y squared. So in this case, what we will need to do is like having x minus y multiplied by x minus y. So it will be multiplying, all of the terms. So it's going to be, first, it's going to be x squared. Then it's going to be minus xy. Then y multiplied by x, it's going to be minus xy. And minus y multiplied by minus y, it's going to be plus, because minus multiplied by minus is plus y squared. So then we have also like terms here. So it will be x squared minus 2xy plus y squared. So we saw like if we got one positive and one negative, x minus y squared, the rule will be the first one squared minus 2 times xy plus y squared. So we can apply both of the rules if we got a positive or a negative one. So that's why sometimes in some books you will have these two of them. When we have two of them positive squared, it will be x squared plus 2 times xy plus y squared. And when we have a negative one, it's going to be x squared minus 2xy plus y squared. So let's see some examples in order to know what to do with this kind of exercise, the square of a binomial. So the first exercise is going to be something like this, 3a plus 2b squared. So remember, from today on, we are going to use the special product rule. We are not going to do the whole multiplication like in the demonstration. So we need to apply the rule. So in this case, we know that it's going to be a positive one. So the rule is going to be the one from x plus y squared. So the rule says to us we need to do the first one squared plus 2 times the first one multiplied by the second one plus the second one squared. So our final answer is going to be 3a to the second power. It's 9a squared plus, in this case, 2 times 3 times 2. It's 12 av plus, and remember 2 squared it's 4, v squared is v, and this is going to be our final answer, 9a squared plus 12av plus 4v squared. Of course, maybe you can skip this specific step. Maybe you can go directly to the answer if you can do it mentally, but I will always put this specific part in order to remember the rule of the square of a binomial. Let's see another example. So in the next one, we have 8x squared minus 5x, and all of the binomial is squared. So we need to apply the rule of x minus y squared, or we can also apply the rule x plus y squared, but we will need to put the specific sign inside the rule. So let's see what can we do. If we want to use the a part or the b part, so let's see with the a part, if we want to apply only the first rule, maybe only remember this rule, not the second one, we can apply it because we can see like it's the first term is squared plus 2 times the first one multiplied by the second one plus the second one squared. So if we do that specific one, we will get 8 squared is 64. X squared is squared. Remember, we need to multiply the exponent. So 2 times 2 is 4. The next one is going to be 2 times 8 times minus 5. 8 times 5 it's 40 times 2 it's 80. So it will be minus 80. We have x squared and x to the 1. So it will be x cubed. Then the second one is squared is going to be minus. Squared is going to be plus. So we will get 25 x squared. So that's applying only the first rule. Like maybe you don't need to remember this specific one. If we remember the first one, we can always apply it. Also, if it has like a negative signs. So let's see. If we want to use this specific one, the second one, we need like to put it like a 8x squared minus 2 times 8x squared. We won't put the negative sign inside because the rule tells us to put it outside. So we don't need here to put the signs of the terms because we know that specifically when we have a positive and a negative one, the first term is going to be positive, the second term is going to be negative, and the third one is going to be positive. So if we use this rule, the first one, we need to use the signs inside the parentheses. If we use the second rule, then we don't need to use the signs. So why? Because the sign is already used in the rule. So that's a very important thing you need to remember, because that's the most common mistake in this type of exercise, putting also the negative terms of minus x. No, if we are using the second rule, then we don't need to use the signs of the terms. We will always use the terms in a positive way. So that's very important for you to remember. So let's see, if we apply the second rule, we will use 64 x to the fourth. Then it's going to be minus 8 times 2, it's 16, times 5, it's 80 x cubed, plus 5 squared is 25 x squared. So then, if you saw, we can use the first rule or the second rule, and we will get the final answer, the same one. But it's very important to remember, if we are only using the first rule, we will need to put the signs of the terms inside the parentheses. If we are using the second rule, then we don't need to use the signs. Both terms, we are going to use it as positive terms. So let's see some other examples. So let's see a third example when we have fractions. Don't worry, it's the same way. It doesn't change very much. So the rule tells us we have here something that it's both of them are positive. So it's like having x plus y squared. So the rule tells us we will have the first one squared plus 2 times the first one multiplied by the second one plus the second one squared. So the answer is going to be, remember, when we get the square of a fraction, it's like multiplying the fraction 2 times. So remember this, because if we get the square of a fraction, it's going to be the square of the numerator and the square of the denominator. So we will get 9 quarters. Then it will be m. 3 times 2 is 6. Then we will get, it's like having number 1 here. So it's like multiplying 2 by 3 halves by 7 fourths. So we can simplify this 2 with this 2. It will be plus 21 over 4 m cubed n squared plus, and then it's going to be the numerator squared. 7 squared is 49, 4 squared is 16, and it's going to be 2 times 2 is 4, and this is going to be our final answer, 9 quarters of m to the 6 plus 21 quarters of m cubed n squared plus 49 over 16 and to the fourth. So remember, if we have fractions, it's the same process. It's only applying the rule of a binomial squared, or also called the square of a binomial. Let's see another example. So what happens when we have fractions and also letters as exponents? Don't worry, it's the same process. So this one, it's like having x minus y squared. So remember, we want, or we can apply rule number 1, but we will need to put the negative signs inside the terms, or we can use the second one using both terms as positive ones. So here I'm going to apply the second one, that it's the most common use in books, applying the second rule. That means applying one rule when we have the two positive, and another rule when we have a positive and a negative. So I will apply the second rule. The second rule told us to have the first term squared minus 2 times the first term multiplied by the second one, but remember we are putting both of them positive ones because the negative sign is already put it in the -2, plus the second one squared. So in this case, don't worry, it's the same part. Remember, a fraction squared, it's squaring the numerator and also the denominator, so it will be 4/25. Then what will happen with the letters, I will do it in 2 steps for those that maybe can understand. It's multiplying exponent by exponent, the power of a power of a power. Then the second term is going to be negative. We can simplify this 2 with this 4, and we will get only a 2 on the bottom part. It will be also divided by these 2, so it will be 3/5. Here it will be x plus to the v plus 3 and y to the 5 minus v. Remember, we cannot join or add these powers because the powers of x are not the same that powers of y. We will need to have the same base to can add the powers. And the next one is going to be plus 9/16, and it's going to be y to the 5 minus v multiplied by 2 because it's power of a power. So the final answer is going to be 4/25 x to the 2v plus 6 minus, it's going to be 3/5 of x to the v plus 3 y to the 5 minus v plus 9/16 y to the 10 minus 2v. So this is going to be our final answer. So in this case, remember, the idea is that maybe when we are using these for many days, we will be able to do it maybe mentally, like saying this one squared is going to be the first term squared minus 2 times the first one by the second one plus the second one squared. So the idea is like we can simplify this process. Maybe we can skip some parts, or maybe we can do it all by mind using the specific rule of the square of a binomial. Let's see a last example. So what happens when we have two negative ones? We haven't done the specific one when we have two negative ones. So in this case, we are using the first rule, but we would use the specific signs inside the specific terms, like we did it on the first one that it has a positive and a negative one. So in this case, we will apply the rule of x plus y squared, but using the sign of the specific terms inside the term. So it's going to be the first one squared plus 2 times the first one by the second one plus the second one squared. So the final answer is going to be negative multiplied by negative, it's positive, so it's going to be 7 squared is 49. It's going to be x a plus 3 multiplied by 2. I know you can do it by mind, but I will do it with the steps. Then it's going to be plus multiplied by minus is minus, multiplied by minus it's plus, so it's going to be plus. 7 times 3 it's 21, times 2 it's 42. We will have x. In this case, we can add the powers because they have the same variable, in this case x, so we can put together the powers and add them, and we will have minus 3 squared it's plus 9x, and it's going to be 2 multiplied by 4 minus a. So in this case, it's going to be the final answer, 49x to the 2a plus 6. Here we will have a minus a, so it will be plus 42x to the 7 plus 9, and it's going to be x to the 8 minus 2a. So in this case, maybe if we want to order this specific answer, because the second one doesn't have letters, we can order it like 49x to the 2a plus 6 plus 9x to the 8 minus 2a plus 42x to the 7th power. But using the specific only rule of the square of a binomial, we will get this specific answer. So now you can do the activity of the square of a binomial.